Hello, good morning friends. How are you? Hope you are enjoying. आज हम चलेंगे कॉम्प्लेक्स नंबर के चौथे लेक्चर की तरफ. लेक्चर नंबर 4 ऑन कॉम्प्लेक्स नंबर. Today we'll discuss property of conjugate. Number 1, if z is any complex number, then z conjugate is same as z. Let z is what? X plus iy be a complex number where x, y belongs to real number and I is what? Root of minus 1. Therefore, z conjugate is what? X minus iy. So, z conjugate ka conjugate will be x plus iy, and x plus iy is nothing but z. Therefore, z conjugate is what? Then property number 2 is what? Z plus z conjugate is 2 times real part of z. Let z is equal to x plus iy be a complex number where xy belongs to a real number. In this only third also let me give you number 3. Z minus z conjugate is what? 2i times imaginary part of z, where xy belongs to R and I is what? Root of minus 1. So number 2 is what? Z conjugate is what? X minus iy. Therefore, z plus z conjugate x plus iy is z plus x minus iy is its conjugate. Iy will get cancelled. X plus x is what? 2x, which is 2 times x is known as real part of z. And second one is z minus z conjugate, third one. X plus iy minus z conjugate is x minus iy will give you x plus iy minus x plus iy will give you 2iy, and y is what? Imaginary part of z. So z minus z conjugate is what? 2 times imaginary part of z. If z is equal to z conjugate then imaginary part of z will be 0. See, x, z is what? X plus iy. And z conjugate will be what? X minus iy. Since z is equal to z conjugate, therefore x plus iy is equal to x minus iy. Bring all the terms on this side. So 2iy is 0. So this will be 0 when y is 0. Y 0 means imaginary part of z is what? 0. Imaginary part of z is 0 means z is only x. Is purely real. Property number 5th is if z plus z conjugate is what? 0, then z is purely imaginary. Z is x plus iy. Therefore, z conjugate will be what? Since z plus z conjugate is what? 0. So x plus iy plus x minus iy is 0. Iy will get cancelled. So 2x is what? 0. So x will be 0. X is 0, so z will become what? 0 plus iy is purely imaginary. Next property is z into z conjugate is mod z square. Z is what? X plus iy. Therefore, z conjugate will be what? X minus iy. Consider z into z conjugate. X plus iy into x minus iy will give x square minus I square y square. I square is what? Minus 1. Z into z conjugate is what? Which is same as mod z square. Property number 7th is if you take two complex numbers, z1 plus z2 conjugate is what? z1 conjugate plus z2 conjugate. Let z1 is what? X plus x1 plus iy1 and z2 is what? x2 plus I y2. Be two complex numbers. So z1 plus z2 is what? x1 plus I y1 plus x2 plus I y2, which is x1 plus x2 plus I common y1 plus y2. What is z1 plus z2 conjugate? x1 plus x2 minus I into y1 plus y2. And when you open this, you'll get x1 plus x2 minus I y1 minus I y2, which is same as x1 minus I y1 plus x2 minus I y2, and this is z1 conjugate plus z2 conjugate. Similarly, z1 minus z2 conjugate is what? z1 conjugate minus z1 into z2 conjugate is what? z1 conjugate into z2 conjugate. And 10th is what? z1 upon z2 conjugate will be same as z1 conjugate upon z2 conjugate. In this case, provided z2 should not be 0. So these are properties of conjugate. Next is properties related to modulus. In this first one is mod z is equal to 0 implies real part of z is equal to 0 and imaginary part of z is equal to 0. See the proof of this. Let z is equal to a plus or x plus iy be a complex number. Mod z is what? Root of x square plus y square. Therefore, mod z is equal to 0 will imply root, and this will be 0 provided x square plus y square is what? 0. So x has to be 0 and y has to be 0. X is what? Real part of z is 0 and imaginary part of z is 0. Next is modulus of z is equal to modulus of z bar is equal to modulus of minus z is equal to modulus of minus z bar. See the proof. Let z is what? X plus iy. Mod z is what? Root of x square plus. In this case, z conjugate will be what? X minus iy. So this implies mod z conjugate will be what? Root of x square plus y square. Minus z will be what? Minus x minus iy. So this implies modulus of minus z is what? Root of x square plus y square. Then minus z conjugate will be what? Minus x plus iy. So this implies modulus of minus z is what? Root of x square plus y square. The next is minus of mod z is less than or equal to real part of z is less than or equal to mod z. And same way, minus mod z is less than or equal to imaginary part of z is less than or equal to mod z. Let z is what? X plus iy. Real part of z is what? X, and imaginary part of z is what? Y. And modulus z is what? Root of x square plus y square. Root of minus root of x square plus y square is always less than or at the most equal to root of x square, because y can be and this is less than or equal to root of plus x square plus y square. So modulus of z minus z is less than, this will give you what? Real part of z, x, or let me write this, is less than or equal to plus mod z. Therefore, real part of z same way we can write root y square minus root x square plus y square less than equal to root y square less than equal to root. So minus mod z less than or equal to real imaginary part of z and this is nothing but mod plus z. Okay, next is z into z bar is mod z square. Z is x plus iy and z bar will be what? X minus iy. Consider z into z bar x plus iy into x minus iy will give you x square minus I square y square. I square is minus 1, which is mod z square. A number fifth is modulus z1 into z2 is mod z1 into mod z2. Z1 is x1 plus iy1 and z2 is what? x2 plus iy2. Therefore, z1 z2 is what? x1 plus iy1 into x2 plus iy2 will give you what? x1 x2 plus I into x1 y2 plus I into x2 y1 plus I square y1 y2. x1 x2 plus I common x1 y2 plus x2 y1 minus y1 y2, which is x1 x2 minus y1 y2 plus I into x1 y2 plus x2 y1. Therefore, modulus of z1 z2 is what? Root of x1 x2 minus y1 y2 square plus x1 y2 plus x2 y1 square. Now when you expand it, you will get x1 square x2 square minus 2x1 x2 y1 y2 plus y1 square plus into y2 square. This will give you x1 square y2 square plus x2 square, and middle term will be what? 2 x1 y2 x2 y1. Now this and this will get cancelled. So what is left? x1 square x2 square plus x2 square y1 square plus y1 square y2 square plus x1 square y2 square. Now we can write, we'll take x2 square common. So in bracket x1 square plus y1 square plus y2 square common. Again you will get x1 square plus y1 square. Now take x1 square plus y1 square common. So you get x2 square plus, which is same as root of into root of x2 square plus, and this is modulus of z1 into modulus of z2. Therefore, modulus z1 z2 is same as mod z1 into mod z2. In general, modulus z1, z2, z3 into zn is same as mod z1, mod z2, mod z3 into mod zn. The next one is number 5. Modulus z1 upon z2 is what? Mod z1 upon mod z2. Consider z1 upon z2, x1 plus iy1 upon we are dividing two complex numbers. So method is what? Multiply divide by conjugate of denominator. x1 plus iy1 upon x2 plus iy2 multiply divide by x2 minus iy2 upon x2 minus iy2. Multiply numerator with numerator, so we'll get x1 x2 minus x1 y2 I plus x2 y1 I minus I square y1 y2 upon x2 square minus I square y2 square, which is equal to x1 x2 plus x2 y1 minus x1 y2 I common plus y1 y divided by x2 square plus y2 square. So this will give you x1 x2 plus y1 y2 together and x2 y1 minus x1 y2 I divided by, you can separate it, you'll get x2 square plus y2 square and here also plus y2 square. Now we go to what? Modulus. So mod of z1 upon z2 is what? Modulus of this will give you what? Real part square. x1 x2 plus y1 y2 upon x2 square plus the whole square plus x2 y1 minus x1 y2 upon the whole square. Now x2 square plus y2 square LCM will come outside from root sign. So inside root you will get x2 square plus y2 square will come outside. And numerator if you expand you will get x1 square x2 square plus 2x1 x2 y1 y2 plus y1 square y2 square plus x2 square y1 square minus 2x1 x2 y1 y2 plus x1 square y2 square. Now this middle term will get cancelled, plus minus. We'll take x1 square plus x2 square y1 square plus y1 square y2 square plus x1 square y2 square divided by x2 square plus y2 square. Now we'll factorize it. Take y1 square common. So x2 square common in first. x2 square common, so we'll get x1 square plus y1 square, and here we will take y2 square common. So we'll get x1 square plus upon x2 square plus y2 square. Now take x1 square plus y1 square common. Into divided by x2 square plus y2 square. Now remove it from root, separate it. x2 square plus y2 square divided by now this can be written 2 times root of this into root of again. One root will get cancelled. So what is left? Upon root x2 square plus y2 square, which is nothing but modulus z1 upon modulus. Therefore, we have started with what? Modulus z1 upon z2 is equal to mod z1 upon mod z2. Then property number 6. See the next property of modulus. Modulus z1 plus z2 square is same as modulus z1 square plus modulus z2 square plus 2 times real part of z1 z2 bar. See this. Consider is what z1 plus z2 into z1 plus z2 bar. The reason is what? Mod z square is what? Z into z bar. Which is equal to Z1 plus Z2 into Z1 bar plus Z2 bar. So this will give Z1 into Z1 bar plus Z1 into Z2 bar plus Z2 into Z1 bar plus Z2 into Z2 bar. Now Z1 into Z1 bar is what? Mod Z1 square plus Z2 into Z1 bar is what? Mod Z2 square plus Z1 Z2 bar plus Z2 Z1 bar. Mod Z1 square plus mod Z2 square, and this will give you what? 2 times real part of Z1 Z2 bar. Then 7th is what? Modulus of Z1 minus Z2 square is equal to mod Z1 square plus mod Z2 square minus 2 times, here it is what? Plus 2 times, and here it is what? Minus 2 times real part of Z1 Z2 bar. Consider modulus Z1 minus Z2 square. It is nothing but Z1 minus Z2 into Z1 minus Z2 bar, which is equal to Z1 minus Z2 into Z1 bar minus Z2 bar. Z1 Z1 bar minus Z1 Z2 bar minus Z2 Z1 bar plus Z2 into Z2 bar. This will give you what? Mod Z1 square minus common Z1 Z2 bar plus Z2 Z1 bar plus mod Z2 square. So mod Z1 square plus mod Z2 square minus Z1 Z2 bar plus Z2 Z1 bar, which is mod Z1 square plus minus 2 times real part of Z1 Z2 bar. See property number 8, modulus Z1 minus Z2 represent what? Modulus x1 plus iy1 minus x2 plus iy2, which is same as x1 minus x2 plus I into y1 minus y2. And modulus of this is what? Root of x1 minus x2 square plus y1 minus y2 square. Distance between x1, y1 and x2, y2, which is same as distance between z1 and, so modulus of z1 minus z2 is what? Distance between z1 and z2. And ninth is modulus z raised to n is same as mod z raised to n. N belongs to Q, rational number.